Hi everyone, welcome to my presentation. My name is Muhammad Irfan bin Muhammad Sanip. I'm from 4 BEKG Section 1. In this presentation, I would like to talk about my final year project, which is remote controller system for high volume, low speed HVLS fan for Suria Giant Fan Services Sendirian Berhad. First of all, there are 6 parts that I divided in this presentation, which is the introduction, the problem statement, the objectives of my project, methodology, preliminary result, and lastly, conclusion. Without further ado, let's get started. This project basically applies the same concept as a regular home ceiling fan. At this current moment, remote controller systems are used at any electronic device such as television and fan. So, in this project, remote controller system is used to automate the speed of HVLS fan according to consumer desired speed. Moving on to project background. HVLS can be defined as a fan that produces high volume of air with low fan rotation speed. HVLS fans technology is based on a principle that large groups of slow-moving air are more efficient to lower human body temperature than fast-moving air. The HVLS fans produces a floor jet circulation. The air moves from the fan blade downwards in all directions and across the floor to the wall and back in the direction of the fan blade. Suria Giant Fan Services Sendirian Berhad have two series of HVLS fan, which is Grande series using BLDC motor and Euro series using induction motor. This project purpose is to develop remote control system to change the speed of the fan for Grande series. As you can see in this slide, this is the comparison of specification between HVLS fan and standard ceiling fan. There are huge difference between HVLS fan and standard ceiling fan based on the size, the power consumption, the volume, and the speed of the product. So, why need to develop this system? Because, first of all, Suria Giant Fan Services Sendirian Berhad is one of the well-known company that produce HVLS fan product at Malaysia. It can be superiority to Suria product compared to other competitors at Malaysia. Secondly, there are many inquiry coming from the customer asking for the remote control system. Suria customer request the remote control system so that they can on or off and change the speed of the fan without go to the control room or main switchboard as usual. Let's turn now to problem statement of this project. Most researchers just research about the HVLS fan structure and execution. The remote control system of HVLS fan has not been invented yet during this time. None of them try to develop remote control system to control the speed of HVLS fan. All of the HVLS fan using the analog control that attach at the main board of the fan. Furthermore, moreover, Suria Giant Fan Services Sdn Bhd received some requests and complaints about the remote control for change the speed of the HVLS fan. The customer asked for the remote control system as they having some difficulty to change the speed of the HVLS fan according to the environmental temperature sometime. They need to go to the main switchboard of the HVLS fan in order to on or off and change the speed of the HVLS fan. The problem also happens when the MSP is too far and difficult to achieve, which troublesome the consumer sometimes. The graph shows the annual sales of Suria Giant Fan Services Sdn Bhd since 2014 to 2020. As you can see, there is an increase in units sold every year. This clearly proves that the growing demand for giant fan usage every year is increased. Next, as you can see, this is the result of a survey conducted on 10 previous customers of Suria Giant Fan Services Sdn Bhd. This result shows that 8 out of 10 participants require the remote control system for the HVLS fan. The opportunity of this project are to produce the first HVLS fan that has remote control system, to realizing customer requests, to build a project that can be commercialized, and lastly, to improve marketing quality and profitability for Suria Giant Fan Services Sdn Bhd. Now, let's move on to my next topic, which is the objectives of this project. There are three objectives of this project. Firstly, the objective is to design remote control system for control the speed of the HVLS fan of Suria Giant Fan Services Sdn Bhd by using Proteus 8 Professional. Secondly, to analyze the circuit of this controller as the receiver to control the speed of HVLS fan. And last, to verify the effectiveness of the proposed design through the HVLS fan system. Okay, now I like to look at our next topic, which is methodology of this project. As you can see, this is the flowchart of overall methodology used to complete this project. At the first stage, I discover a problem and research some objective. Then I do some literature review. For the exploratory research technique, I do historical data and customer inquiry. So from both of it, I get the problem statement of this project. So after that, I come up the questionnaire and research some data study about the HVLS fan and do some observation. After that, I do some system flow for this project, which is I've planned to use Arduino Uno. So IR remote controller that attached to the Arduino Uno and then test. After success on coding, I do some research for the controller circuit for controlling DC voltage and design the circuit with Proteus 8 Professional. And then I test until I success and get some sample, and then I write some report for chapter 1, 2 and 3 and then present this project proposal for PSM1. For the plan on PSM2, after success to develop proper remote controller circuit, I will assemble the circuit and do some PCB layout and then test it again. So after confirm it, then I will design and construct casing for the product and install it into HVLS fan. Then after that, I will collect the data and analyze, compare between the analog controller and the digital controller and finding some solution. And then after that, recommendation and conclusion and report writing for complete the PSM. Okay, this is the system flow of this project. So we start on the DC power supply to supply the controller circuit. So the controller circuit will on, and then they have two mode, which is on mode and off mode. So one button 1, 2, 3, 4 is set for different speed of HVLS fan, and then the remote control will send the data to the infrared receiver that attached with Arduino Uno, and then the host receiver will trigger the controller circuit to process instruction for fan speed. And then at the off mode button is set at the coding. So it's the same, send data to infrared receiver, and then the host receiver data will instruction for non-activating fan speed. So that's basically same concept as the regular shielding fan. Okay, next, this is a software development flowchart. So I start on doing research for suitable component and circuit, and then try to develop a circuit by using the Proteus 8 Professional and simulate it until I success. If fail, and then I redesign and research more about the component. So after success, I will proceed for hardware installation. So for the software development of control circuit, I use Proteus 8 Professional that can design circuit schematic for circuit development and simulate the circuit run advanced frame by frame. And Proteus 8 also can design PCB from circuit schematic that I developed in it. As displayed on the screen right now is the hardware development flowchart. So after software development is finished, I can construct the PCB and assemble all the components, and then testing. If there any fail on the circuit, then troubleshoot till success, and then after success it will be construct the casing for the proper product and then install it to the HVLS fan and test the output. Move on to the next slide. So this is basically my activity during this semester, finishing the PSM1. So next, I like to look at next topic, which is preliminary result. As you can see, this is the current circuit of HVLS fan. Basically, this project focus on the controller part. So the flow is from RCCB to the MCB and to direct online. One wire to the AC-DC converter for supply the controller circuit, and then the control circuit will connect to the PLDC motor using 4-core signal wire. So this is the idea to change the analog controller to remote control system. So that's the picture of current controller. So this is the block diagram. So for the input, I will use AC-DC converter and IR remote control. So the process will be the Arduino Uno attached with the IR remote control receiver. The control circuit need to be developed. Then the output is BLDC motor of the HVLS fan, which is 0.75 kilowatt to 1.5 kilowatt, depends on the size of the blade. This motor can run with single phase or 3-phase. So in this control circuit, I developed 2 control circuit. So now let's go to the first circuit that I developed. This is the first circuit block diagram. For the switching, use AC-DC converter to turn on the Arduino Uno and attach with the IR remote control receiver. Then we connect to the bipolar junction transistor BJT NPN to control the ground connection. For voltage control, use AC-DC converter but at higher voltage than the switching because some losses due to the multiple fixed voltage regulator. So I use relay and then connect to the fixed voltage regulator and load. So basically this is a switching circuit and this is the voltage circuit. So as you can see, this is the circuit number 1 that I developed. So this circuit contain fixed voltage regulator, which is I use LM7805 for 5 volt DC output, LM7806 for 6 volt and the others. Then number 2, I use relay 5 volt to control the connection to the ground, and then I use BJT 2N2222 for the switching, and then I use the resistor 330 ohm. Then I use the LED as the load for this current moment, and then DC voltage source. So the push button is considered the input that triggered from the Arduino Uno. Okay, finish for the control circuit number 1. So we get back to the block diagram and we looking for the control circuit for circuit number 2. So basically both of the circuit are the same at the switching. The difference is at voltage control. So at circuit number 2, I use the variable voltage regulator that control the voltage by using multiple parallel resistor. So this is basic circuit for the voltage control and the switching. So the component used for circuit number 2 is the variable voltage regulator, which is LM317T. Number 2 is capacitor. 0.1 microfarad and 10 microfarad as the load. And number 3 is BJT PN2222, and then multiple of resistor 100 ohm, 710 ohm, 900 ohm, 1.3 kilo ohm and 1.5 kilo ohm to control the voltage output. And number 5, of course, DC voltage source. So this circuit equation is V out maximum equals to 1.25 volt, 1 plus R6 over R1 plus current adjuster multiple with R6. So R6 is set to the maximum output voltage that can be delivered. So these two circuit is not the final circuit for this system. So I need to research more to stabilize the output, get the exact result to the application of HVLS fan. Okay, that's all for the block diagram. So this is my coding for the IR remote controller that attached at Arduino Uno. So this is some video that I record to prove the system coding is success. So we go to the expected output that I want for this project. So number 1 is I want the voltage output of DC 5 volt, 6 volt, 8 volt and 10 volt to control the speed of the HVLS fan. And number 2 is the current output DC based on BLDC motor rated current. The minimum current is 2.7 amp and the maximum current is 5.2 amp. Okay, now I will talk about the ongoing progress. So first, I still analyze a suitable voltage regulator for the control circuit. And number 2, searching for the article based on this project. And I also do some research about microcontroller and multiplexer for circuit 1 that I explained before. And number 4, I also do some research about making own remote control that's suitable for HVLS fan market, because this product will be used, so I need to develop own remote control to be proper product. And last, writing report for chapter 1, chapter 2 and chapter 3, which is introduction, literature review and methodology. That's all for the ongoing progress that I do right now. Okay, so that's bring me to the end of my presentation. So basically this project is about to develop the remote control system of HVLS fan so that the customer can use the HVLS fan same as they use a regular ceiling fan at their home. I hope this project will success and can be implemented to the HVLS fan and can be commercialized. So the slide right now shows all references that I use to do this presentation and report. Okay, that's the end of my presentation. I hope you enjoy it. Thank you.